Hello, everyone. We are live. Hello, Frank. How are you
Hi,
doing?
Denis. Good, good, and you?
Super good. As we were chatting, I landed from the air a couple of hours ago. Was attending one of the largest conferences in the United States. It's called All Things Open. We can briefly talk about it in a minute. So probably I still look good because I had a very short night, like for sleep. But feel relaxed anyway. That's what you get used to. How about you? Like, what you're in a hotel? What's happening?
Yeah. I also have many conferences. Last year I was in Davos. Last week I was in Davos, Morocco, and this week at the same venue there is the Java Croatia and the Oracle user group, and I have talks in both of them. So yeah, that's a week packed of presentations and meeting people. That's nice. Yeah.
Yeah, the conference. Yeah, this conference season was kind of busy, and I think that many folks. I'm talking to some of the folks that I see regularly at conferences in the United States, and some of them I'm already kind of wanna just go back home and forget about conferences for this year. Just people need to restore. It's like yesterday at All Things Open, we had another conversation with Oleg, with Oleg from Test Containers. He is a developer advocate for test containers. Many of us know test containers and hopefully use test containers. And he was telling, yeah, his next conference is KubeCon in the United States, and then that's it. And
Yeah.
then he just, can just relax and work, do something online, and just to restore.
But September and October is always really busy. Then after that, you start to see the end of the year. Yeah.
Yep. And hello, yes, Eshwar. Hello, Eshwar. Thanks for joining us.
Hi,
Thanks for
Ishwara.
joining us here regularly. Nice to see you. And by the way, tell us how is your YugabyteDB journey going? Have you already started using YugabyteDB or testing YugabyteDB? So because we see you coming every live stream, and we're curious what's happening with your YugabyteDB journey. Feel free to share.
Yeah, all feedback is good in the chat or later on Slack. Yeah.
Yep. Just to remind those of you who are watching us for the first time, YugabyteDB Open Hours are for the YugabyteDB and broader PostgreSQL community. So here is you can come to us, ask questions, bother us with your problems or challenges. We always will be happy to take your questions. If possible, we will answer them online. If not, we can always carry on offline on our Slack channel. But we also always come prepared. We select one of the topics that we want to focus on. We want to do deep dive. We want to do live coding. And today we have a special guest. We will bring him to the stage shortly to talk about PeerDB. That's another one of the latest additions to the Postgres ecosystem, new platform or framework. I will let Sai define properly the product, because I know after looking at it, I defined it as a platform, but nevertheless, I might be wrong. That allows you to stream changes from your Postgres databases to a variety of other target sources. But speaking about Postgres, actually, right? Speaking about Postgres, because I promised to quickly tell about All Things Open. All Things Open is one of their famous conferences in the United States. I managed to come there for the first time, and I was impressed. We had almost 4,500 people at the conference, and they are almost returned to the pre-pandemic level. It's in Northern Carolina, nice place. It's in Raleigh, and Raleigh. Those of you should know Red Hat. Everyone knows Red Hat. Red Hat's headquartered there, and many other high-tech companies have offices there. And I was surprised to see what was happening at the conference. There were so many Postgres people around. We had a Postgres booth, dedicated Postgres booth, that was hosted by community members. We have, for instance, we had Dave Kramer, who is contributed to the GDBC driver. He also my kind of neighbor in Florida. He lives in Orlando. I live in Tampa. And we had also Postgres companies. We had Yugabyte booth. We had Neon. We had folks from Neon. By the way, Frank Raouf was sending you warm welcome and warm
Yeah, he
hello.
was in Morocco last week.
Yeah,
That's
yeah,
funny. We
yeah,
we meet
yeah,
people that go to the same conferences.
yeah. FaraDB folks, I met with the founders of the FaraDB, and Nice, nice. Like it's also EDB for sure, and some other companies. So like I was impressed to see like so many Postgres people were around. So Postgres is getting traction, and Postgres people are going to the developer conferences, and developers are interested in the databases. What are your observations? What are your observations at the last conferences? At the
Yeah, the same. I mean, at the Java conference, I had a session on microservices and databases, and the room was full. I mean, yeah, in developer conferences, people are interested about talks about databases, but with a developer point of view, because I also discussed with people who kind of complain that they submit to developer conference, but that they are not taken, but probably they submit something that is more for DBAs than for developers. So you need to have the right point of view to so that developers see the value of learning something more on SQL or databases.
I mean, yeah, in conferences there is a high competition. I mean, like even like if, let's take this all things open example. In my case, I was I went there for the first time and I went there as a speaker, but I was submitting to this conference like for 5 years in a row, and I was rejected all the time. So you just need to. It's always like if you like a conference, if you want to that conference, yes, you need to be experienced, you need to be valuable, you need to create something that is useful, and eventually, if you keep doing this, the stars will interconnect, and they will pick you sooner or later, hopefully.
Yeah, but that's a good message that do not for people, for new speakers who submit and say, "Oh, I was not accepted." Just continue, because conferences have also a lot of submissions. There are a lot of very interesting talks. So yeah, it's
Yeah,
kind
keep
of a
trying.
lottery. You just play, and sometimes you get it.
Yeah, keep trying, and also as a good as long as we are talking about like final recommendation that many give. Even if you're just starting the journey, you want to speak, you have a story experience to share, but it's hard to get to one of the like big major conferences because the competition is high. Start with local meetup groups,
Yeah.
and sometimes many of local meetup groups are hosted and organized by those who also organize big conferences. So which means that they will see you, you will be able to present in front of a smaller audience, but it's community, people who would come to listen to you. And then you are building practice, you are building relations, and you might be like people will start mentioning, like noticing you. And some of those organizers might be organizers for conferences. And when you will be submitted to that conference, they will already remember you and they'll, oh, that guy is
Yeah.
smart. He was talking, his talk is valuable. Let's get him in.
That and also self-confidence, because when you see that you have something to share, then maybe you have more ideas of topic to submit. Many people think that everything is already published, done, and they have nothing to share, but no. Everything, every experience, customer cases, new products, uh,
Mm-hmm.
everything can be shared, and
Mm-hmm.
everyone can be a speaker, actually. um, People should not think
Agree.
that speakers are special or especially extrovert, or that's not the case. It's just normal people.
Exactly. Okay. Yeah. Okay. Enough about conferences, because our attendees are already reminding us that folks like that we're already getting questions about PeerDB.
Cool.
Okay, but like what the happening? Like folks are joining. Yeah, like that's a warm up at least, folks. Sorry, we don't have a one-on-one with Frank. We usually just discuss what happened during the live streams. Hopefully, that's also interesting for you. But nevertheless, yeah, the first question is from Amit. Does PeerDB works with YugabyteDB as well? My thought is it should, since YugabyteDB uses Postgres query layer. And we will let Sai, co-founder of PeerDB, to answer this question, Amit. So stay tuned. Let's bring Sai to the stage. Hello, Sai. Hello, our
Hey
friend.
Dennis. Hey
Hey,
Frank. Thanks for inviting me here. So yeah.
No,
it's a pleasure.
thanks for reaching out to us, because that's actually a good example. I mean, you created this new excellent technology. We wish you luck, and you reached out and telling, hey, like it works. Answering the first half of the Ami's question, it does work with YugabyteDB, because otherwise I probably would be reluctant to reach out to us, and he would explain why. But before we start, like, what's where you're right now? Just
Yeah, so I'm currently, interestingly, at a conference. So I'm at the DBT's annual conference called Coalesce, right? Like, and it's interesting that, like, I mean, I don't see many Postgres community folks here, so I'm trying to bear that flag, Denis and Franck. But I'm also at a conference. I'm at a hotel, like taking the dinner. So yeah.
yeah, when I look at your background and at Frank's background, it's obvious that you're not home. It's like you're somewhere.
Yeah.
But
It
you know,
does
Frank,
seem like a hotel, right? So yeah.
yeah, but like Frank, it looks like Sai is staying in a nicer hotel. It looks much better. I mean,
Yeah, I'm in Croatia and it's a nice place. Yeah,
yeah,
they
okay,
do a conference also that in a smaller island, and then
okay.
people are all together, and it's easier to meet people, and sponsors also like it because people cannot escape. They are all around.
That's a good point. Yeah, just come and never go. Okay, Sai, please introduce. Let's start with the basics, right? Introduce yourself to the folks who are watching us, because you're very experienced in Postgres. So, like, tell your Postgres story, and how has this happened that you finally decided to found your own company?
Yeah, thanks, Denis. Right. So, yeah, so I'm Sai and I'm the CEO and co-founder of PeerDB. And at PeerDB, we are basically building a native data movement tool for Postgres. I'll come to PeerDB very soon. Some background about myself, right? Like before PeerDB, I was working at Microsoft, and I was leading solutions engineering for Postgres services on Azure, which included Flexible Server and Citus. Basically, I worked there for like 4.5 years. And prior to that, like I was working at Citus Data. I was a pretty early engineer at Citus Data, and I worked there for like 4 years. And just to set some context, right, Citus basically did build like a distributed Postgres option, right? And I started off as a solutions engineer there, right? Like and then Microsoft acquired Citus to build out their like distributed Postgres offering, right? Like which is in the same boat as Yugabyte or Spanner or Cockroach, basically, right? So since the past, like 8 years, I have been very much in the Postgres space, and I was a solutions engineer, right? I got a chance to mostly work with customers, right, helping them with starting from qualifying the right use cases to data modeling to migrations and all of that, right? So that's what I did. And the reason I started PeerDB is actually out of the experiences that I had at Microsoft and Citus. And what I observed was like lack of a native data movement tool for Postgres was really affecting our implementation cycles, right? Like, and what I mean by like data movement for Postgres, right? Like it's like it covers like a plethora of use cases, right? Starting from say database migrations, right? Okay, I have like a fleet of Oracle databases, I have a fleet of like Postgres databases on premise, and I want to migrate them to the cloud. That is one use case, right? Then you have real-time streaming, right? Say you have this Postgres database and you want to stream data in real time to data warehouses or analytical stores to offload analytics, right? Or it could be you're streaming changes from Postgres to queues like Kafka or event hubs, right? Like for off-stream applications to consume and like create business value, right? So across like a plethora of these like data movement use cases where you move data in and out of Postgres, I observed that like customers who have Postgres at the heart of their data stack, right, like storing and moving hundreds of gigabytes of data, tried out existing data movement tools, right? Like, and most of the
Yeah,
time,
that's a question, because you used to, because when you came up with this idea, you were already at Microsoft, and Microsoft,
yeah,
and my understanding, should have all the tools needed to bring data from one environment to the Azure ecosystem. But
yeah.
was that the case or not? Because it sounds
So
like even at Microsoft that was not fully solved.
exactly, right? Like, and the problem that was happening, right? Like it was I mean their existing ETL tools, like it was in Microsoft, we had like Azure Data Factory and we had like Azure DMS, right? And then customers used to try out these tools, but at scale they did not work out of the box, right? Like, and what I mean at scale is like moving hundreds of gigabytes to terabytes, right? Say for migrations or real-time streaming, etc. And the thing that I observed, Denis, was like all these ETL tools are built around the premise of supporting, hundreds of connectors, then supporting native features which would really help customers, right? I'll give you an example. Within Microsoft itself, we wanted to support the copy command as a part of Azure Data Factory, and it was an absolute nightmare because Azure Data Factory at a high level was like had a Windows runtime. It was .NET based, and it had interfaces where, okay, how do I support the next possible connector, then supporting a native Postgres feature, right? So this was the premise, that like it was very hard to build features for these like generalized ETL tools. This happened multiple times, if that makes sense. So yeah.
So yeah. Just let me. I guess I built a picture in my head. So basically, what you're saying, the service, like the DMS service, right? That service that migrates data at Microsoft, it runs on a Windows machine, which means that it was compiled and built for Windows. And we know that Postgres is a Unix. It's like also built on C++, but it depends on Unix libraries and ecosystem. And yeah, if you want to connect from, it's like it definitely should be harder to integrate, not efficient. And like when you're talking about the scalability, you mentioned the scalability aspect, like. And you mentioned like hundreds of gigabytes, like, but how did it exactly impact your like the Microsoft customers? What exactly was happening? Were they unhappy about the latency or throughput or the loading time? Like, what was the challenge?
So the problem was basically, say if you take the migrations use case, right? Like there were a fleet of like Oracle databases that we needed to migrate, and in-house tools like at scale did not work because of the reasons we discussed, right? And then that delayed our like implementation cycles, and then we needed to search partners, right? Like, and those partners were also like generalized ETL tools, and okay, they worked, but like it took like 3 to 4 months of like extra effort to make it work, right? So, and this was not only for migrations, it was even for real-time streaming from Postgres, right? Say, okay, on Oracle you have Oracle Golden Gate and you're streaming data out of like Oracle. Now you need to figure out a solution for Postgres that works at scale, right? Like, and so that was the problem, Denis, if that makes sense. So it used to delay our implementation cycles by 3 months, 4 months, and this happened again and again, which is when we decided that why not build like a data movement tool that is natively built for Postgres, and we started PeerDB, Denis. So
Makes sense. Thanks. This is
So
how
the source will always be Postgres and then optimize for Postgres.
So that's a good question. I think our end goal is to build the go-to data movement tool for Postgres. So this includes moving data in and out of Postgres. So Postgres can be the target or the source, right? So that is more the broader vision, right? But what we are starting with is Postgres as a source, Frank, and we are starting with the real-time CDC use case where we stream changes from Postgres based on the wall log using logical replication slots to a bunch of like targets, which includes databases like queues and storage engines, which we will get into as a part of the demo. We are starting with like the real-time CDC from Postgres, right? But over time, we want to expand to, both in and out use cases where Postgres is both the source and the target, Frank.
Mm-hmm. Okay. And actually, this is an interesting point that you highlighted, because you gave us an example, the migration example problem, right, that you observed at Microsoft. But when I go to the website of PeerDB, and when we had that private conversation with you before, you kind of you was focused on ETL and real-time streaming, saying like, yeah, Denis, we don't want folks just to abuse the PeerDB right now just for the migration, because it's primarily for the ETL real-time. And I think this is actually we can talk about your roadmap later, closer to the end of the stream. But I think that still, even if people see sometimes you want to do a lot at once, but as a startup founder, we understand that you have much less time than any other companies, and you're always running out of money, and something is pushing you forward, which means that you need to take some focus, make it the right way, and then you can carry on.
I think you're spot on, Denis, right? Like, I think we scoped the problem to Postgres, like from a vision standpoint, and now we are scoping it further, right? Like where it is real-time CDC from like, Postgres to like these multiple targets. And we want to have laser focus for coming 6 months to 1 year. And there we want to provide like the world's best solution, right? Like, and for example, I mean, it's not only performance and scale, right? It's also native Postgres features. For example, PeerDB has like, geospatial data type support already. It supports like, stuff like geometry, points, and like, geographies in a very native way on the target data store, right? It's not like stored as text columns, right? It's in Snowflake, it's stored as GeoJSON, etc., right? So we want to take, this real-time CDC use case, have laser focus, and provide like a simple, fast, and a feature-rich solution which Postgres users would like really want, Denis. So
Okay. And before we go, like, because I'm the one who is already also interested in the business aspects of open source technologies and tools. You're open source, right? You're fully open, or what's your license?
So we are ELv2. So
What
that's
is that?
a controversial discussion. So I would say that like, we are free and open, Denis.
Okay.
And
Free and
so
open, but not for Amazon or Microsoft. And they just sell to sell it as a service, or
no, I mean, we just like decided to go with the, more slightly restricted option on the managed service upfront,
okay.
instead of starting with like Apache and like, changing it in the future, right? My spirit was like, let's start with a slightly restricted license, which just like, doesn't allow to build like managed services, but you can, use it for production use cases. You can even distribute it, etc., etc., right? So it was an intentional choice that like, we start with the right thing upfront, then, down the line change things, Denis. So
Okay. And speaking about Y Combinator, you are a resident of this startup accelerator, correct?
yeah.
It's
So
like
we just
how would you describe the experience? Because like for those who don't know what Y Combinator is, that's probably one of the most famous startup accelerators based off Silicon Valley, right, California. Many well-known companies were kind of graduated from that accelerator, and PeerDB team is also there right now. So share your experience, like how this happened. Like, do you see any value? If yes, then what's the value of being a resident there?
I think YC was great, right? Like, so we just graduated like 3 weeks ago, right? Like, and we were a part of the most recent summer 23 batch. And I have known YC since long because Citus was also a YC company, right? Like, and initially when I was at Citus, I had onboarded other YC companies to Citus, right? Like, so I have been like in the, this space since long. So we applied to YC, and I think it was the right choice on multiple fronts, right? Like, number one, we met like some amazing mentors on there. We also met like some amazing founders and batchmates who were doing like different things, right? Like, and now we are like great friends and we can lean on each other, right? Like as a part of the founder journey. That is number two. Number three, it helped on the visibility of the company side also, right? Like we did launches and we moved very fast, by which we launched our open source repository, which is which already hit 1,000 stars, right? Like, and there is good momentum there, right? Like, and that probably wouldn't have happened with before YC, because YC pushed us to launch, right? Because we get feedback, right? And that's the reason probably we are having this laser focus on real-time CDC, because we got feedback that this is one use case where customers have a need, right? And the third was, it also helped on the fundraising side of things, Denis, right? So great mentors, great friends, propelling our company from like a at least focus in one area by launching faster, and last but not the least, fundraising as well. So yeah.
Excellent. Yeah. It truly everything depends on the relations, because at a month ago when I was at the Postgres conference in New York, someone was giving a small talk, like 5 minutes talk about how to earn $1 million, and the point of that was not just to invest in the stock market or like do this and that, but the question was like build relations, know people. People need to know you, and then like if you want, and then let's say Frank, talking about you. I mean, I went to this All Things Open, and like I'm talking to the folks from Neon, from the folks from PeerDB, like, and everyone is talking about you. Like, what the hell? Say like that's the kindest and like that's the best person. Like, what are you doing to the people? Like, I've never seen you in person. Probably I don't feel that magic because you need to kind of. That's the point, right? You kind of when it's virtual, it's all right, it's okay. But when you see someone in person, that's just a different energy. And people like everyone, yeah, we know Frank. Wow, that's like the best brand. Come on, and that's like an example of relations. Like why relations matter. You just people know you. You meet people, you shake hands, you exchange ideas, and then they help you, and you can help them.
and we all that it in being friendly. There is no marketing. There is no pushing product. We are just liking a technology, the ecosystem around Postgres. We build a database. Others are building another database, and we are happy that everything goes around this ecosystem. So yeah.
Exactly. Okay. Yeah, I can talk about this for years, but still, we've probably most of the folks who are watching us right now, or that who would be watching the recording, they want to see PeerDB in action. So let's start with the demos side with PeerDB. And while we will be demonstrating those demos, let's talk more about internals. We will be asking questions like, how do you capture exactly? What did you change with the replication, and etc. etc. Let's move forward. Share your screen, and let's get the demo going.
Awesome, thanks, Denis. So let me share my screen, and
yeah, click this present button. You should see it down below. Okay.
I just
Yeah.
share my screen.
So let's see.
Yeah.
Awesome. So as a part of this,
if you can make the font size on the terminal a little bit. Yeah, whoa. Wonderful. Yeah, let's keep it this way.
I love it. Yeah, so feel free to stop me if there are any questions during the demo. I want to make this like as interactive as possible, right? So in this demo, what I'll be showing is I'll be showing PeerDB replicating data from Postgres, right? Like using the logical replication slot to multiple targets. So I would show Postgres to Postgres streaming, number one. I would show also Postgres to Snowflake. And as an icing on the cake, we will do Postgres to like Yugabyte, because Yugabyte just like worked out of the box, right? So that is the theme of the demo, where I have like a source Postgres database, right? And I'll show you like data streaming in real time to a bunch of like these targets, right? And I would be using the wall log, which is logical replication, as a part of this process, right? So
so you will be just to clarify, you will be using the wall log, the logical replication on the source side, right?
Yes, on the source side.
Okay, yes. let's see, like let's go through your comments, and then I think Frank and I will try to challenge you with some of their internals.
So the first thing I'll show you is I have like PeerDB running, right? Like on Docker, right? Like this is an just an EC2 instance, right? And one unique thing about PeerDB is you can connect to this ETL tool just using the pSQL, right? Like it exposes like a Postgres compatible layer. So the idea is, hey, you can do data movement using just like the Postgres compatible layer. So I connected to PeerDB, right?
And here is like I will be you allowed me to interrupt you. I will be interrupting you.
Please.
I mean, speaking about PeerDB, what language is it written in? C or Rust, or what's your language? And the second question is, does it mean that you implemented from scratch the Postgres wire protocol level, or you also support syntax? What's exactly supported, and how is it supported?
Yeah, that's a great question. I'll actually go to our architecture, right? Like it's all in docs, right? So from an architecture standpoint, right, like we have the query layer, which is what I connected to, right? Like, and this is what users connect to, and kick off their like data movement jobs, right? Like across different data stores, right? Like, and this is Postgres wire compatible, and this is written in Rust, right? And this is just a compute layer, so this can horizontally scale, right? And then on the backend side, like we have the data movement layer, which we call it as the flow layer, right? And that is all written in Go, right? So it's a mix of Rust and Go. And then we use Temporal. We are like big fans of Temporal, which is an orchestration tool which helps you, like schedule jobs, manage jobs, and also like set states, right? Like which takes care of, retries, idempotency, and all of that, right? So we use temporal as the orchestration engine, right? So that's our at a high level architecture. If you want, I can get into this in more detail, but did that answer your question, Denis?
Yeah, so like the query layer, it's in the Rust, and then you have this catalog database. So you use Postgres, standalone Postgres also internal, like for your own needs.
Exactly. So our catalog database is where you store, the information regarding the data stores, information regarding the data movement jobs, which we call as mirrors, basically, right? And it is like Postgres, right? And that's the reason when you connect to PeerDB and do a /d, right? We basically reply it to, the catalog itself. So these are some catalog tables like flows, peers, and all of that. So it is a Postgres database. It can run anywhere. And you when you start PeerDB, you can plug in any catalog, any Postgres database. It's not like packaged with PeerDB, basically, right? You can plug in any Postgres database as the catalog that is. So.
It makes sense. Because I'm familiar, for instance, many API gateways and other technology that support that, gateway meshes. They need to store, let's say, those different routes, let's say, that you configure. And what I see that usually Postgres is selected to another relational database, which makes sense for PeerDB as well. So generally, when you start this in Docker, you have one process for the PeerDB query layer, then you have also Postgres instance running for your needs, and then you also have this layer written in Go, right, that does this workflow like processing.
Yep.
Okay, wonderful. Thanks.
Awesome. Yeah, so the just to show you the setup, right? So first I have like a Postgres database, which is the source, right? And I have like 3 tables here. I have the accounts, branches, and basically tellers. Forget about the history table. So I have like 3 tables that I would be carrying. So I have, if you see, around 1 million rows in the accounts table, if you see, and tellers and branches are like pretty small. So this is the source database that I would be using, right? And I have like a script that I wrote, which would basically do a PG bench, right? Like, so this is the script. If you see, what this script would do is it would insert like a bunch of rows and like update a bunch of rows on the PG bench accounts table on the database that I showed you, which is like the source database, basically, right? So let me go ahead and kick off that script, basically. So it constantly ingests and like updates rows on the source Postgres database, and we can verify that. If you see, like, the rows are changing, right? Like, and there is constantly rows getting added. Any questions so far, Denis and Frank? So
makes sense. Yeah, let's see, like, how do I get this this table and the changes streamed to another database?
Yeah, so I have another database, which is the target database, which is again a Postgres database, right? This can be anywhere. It can be on the cloud. It can be anywhere, basically. And here I don't have like any tables. So forget about this one. This is like just a metadata table, but it does not have the PG bench accounts, like tellers and branches, basically, right? So with PeerDB, my goal is to, real-time stream changes from the source Postgres database to the target Postgres database, right? So that's the goal here. So let me go ahead and connect to PeerDB, right? And this Postgres compatible layer, right, exposes like new commands. The first command we'll talk about is the create peer command. If you see, right, in the PeerDB world, data stores are like just peers, right? Like, so the first command that I'm doing is I'm just running the create peer for the source Postgres database, right? If you see, and this is the one that we were querying and seeing the rows, right? So this is the first command, and the fun part is through this layer you can even query the data of this peer. So you could do like select count star from Postgres underscore peer dot pg bench underscore accounts, right? And then this is the same table that we were querying, but now we are querying through PeerDB, basically.
But yeah, hold on here, for a second, because right now you're connected to your query layer, to the PeerDB query layer. But then,
yes,
like, that's the connection, string. But then you use this create peer command to add information about another Postgres database, right? That is running on a different process.
correct.
And then when you execute this select statement, do you use a foreign data wrapper internally? What's the implementation? How do you get the data from that
So
remote?
we have, so we basically do our own AST translation. So like the query comes in, and then like based on the query, we decide, which peer they should go to, right? Like, because I'm making it aware, right? I'm saying Postgres_peer, right? And then we do the parsing, we do the AST translation and route it to the right peer, Denis. So we don't use the foreign data wrapper.
Okay, so you cannot join tables from two
No.
peers. The goal is to read one or the other. Yeah.
Exactly. You cannot join two peers, right? Like, that's not the goal. I mean, this query layer is more for, okay, I kick off the, streaming, right? And I can validate whether the rows are same. It's like more a fancy thing, I would say, Frank.
That's convenient. That's convenient for sure.
Exactly.
And like what it means that you truly spent a lot of the time on the Citus team, because this is how you work with the Citus, right? You connect to the coordinator, and the coordinator then decides where to route a request.
Yep. So
Yeah.
this is the thing. So this is the source peer. Now I'll go ahead and also create the target peer, which is a separate database, which is a target, if you see here, right? And let me go ahead and create this, right?
And how does your query layer know where is a target or source? Like, you use a special, like, you have this database target label in the create statement. Like, how does PeerDB know what's target and what's source?
Yeah, so like that is the mirror command. I'm coming to that very soon, basically.
For the moment, there are only peers, and you didn't decide the direction for the moment.
Exactly. I
Okay,
just call these names as like Postgres peer and target Postgres peer. But as Frank mentioned, I just created these peers. I did not tell the direction yet, whether what is the source and what is the target.
I have a question. I guess
Yes.
that for the target, you just apply SQL, so you don't need something special. For the source, you need some settings for logical replication?
Yes. So for the source Postgres peer, right? Like we use logical replication for real-time CDC, and a couple of things that are needed is, these are the things, standard stuff, right? Like the wall level needs to be logical on the source. Max wall centers need to be greater than 1. Max replication slots 4.
slots,
So yeah, and then also the user needs to have replication access, basically. Read access and replication access is enough. You don't need write access on the source, basically. And the target is, we don't do any fancy things. It's like plain simple SQL commands, right? So there we don't require any logical replication access and stuff like that, Frank.
Okay, and we've got a question from Eshwar. Let me show this question. Let's answer it right now. We have different types of data sources and platforms from various companies to do data processing, etc. To get the quality of data security, to get the better results, how can we find better platform? I can. It depends. I mean, it depends if your source, for instance, if your source is Postgres, right? We are discussing a solution today, PeerDB. That's what you can do. If your sources are different, then take a look at other technologies. We have Debizium, we have like Kafka is used, and Sai, you also probably might suggest something in your Frank. What are your thoughts?
Absolutely right. Like, so I think if, as Denis mentioned, right, like if you're doing real-time CDC from Postgres to say Snowflake, BigQuery, or like queues like Kafka, Event Hub, etc., and you're doing this at scale, right? Like in the sense that you're moving, say, like tens of gigabytes to hundreds of gigabytes from Postgres to these data stores, PeerDB would be a suitable solution, because I'll get into some of the Postgres native optimizations that we do also as a part of the demo. So we do a bunch of Postgres native optimizations which are unique to PeerDB. But then if you wanted to move from, say, Oracle to Postgres, right? As of now, like PeerDB doesn't support that out of the box. We might do it in the coming 6 months. For that, like there are other solutions that you could take a look at, basically, right? A few that come to my mind, being very transparent, is say, like, I've heard about Stream, right? Like we used to use that like at Microsoft. It was like, not very straightforward, but it worked for customers, right? So you could look at tools like that, right? And in-house like cloud tools like, say, Azure DMS, Data Factory, which are still like generalized ETL solutions, but you could use them if say you're doing Oracle to Postgres migrations and stuff like that PeerDB doesn't support as of now. So
also depend on the price. There is also Golden Gate that is really nice and has a lot of targets and source, but can be expensive also.
Yep.
Okay, yeah, we have questions coming, but I will let you, Sai, finish your demo first, and then focus. Yeah, thanks for asking questions, and we'll get them answered a little bit later. We want you first see the whole process.
Awesome. So the two things I did was I added the source peer and I added the target peer. Next is I'm going to kick off a mirror from the source peer to the target peer, right? And for that, we introduce a command called create mirror, right? Which takes the source peer and the target peer. And I'm specifying the table mapping here. So I'm specifying, PG bench accounts to accounts. So this is the source table. And then this is the target table, basically. And remember that this table does not exist on the target peer, right? And I'm doing it for like branches and tellers, basically. And this create mirror option for real-time CDC from source to target gives you like a bunch of options, right? This is the configurability part, right? Where here I'm saying that, hey, I want to do initial copy, which means that like I want to take an initial snapshot of the data that is already existing, right? Like it's not like I just create a slot and replay the changes from when the slot is created, right? Rather, I want to also do an initial snapshot, right? Like copy the existing data set to the target database, right? And here
And how do you do this? Like, do you guys take a backup, or you just what Postgres actually allows? How?
Exactly. So the way we do this is this is one unique feature that PeerDB has. We have something called as parallel snapshotting, right? Like, so what we do, Dennis, is we start, like, if you're seeing the screen, right? So we start a snapshot connection to Postgres, right? And then we basically stream multiple tables in parallel using that snapshot, right? And one capability that PeerDB has is if you have super large tables, right, say terabytes of data present in those tables, you could parallelize load for that single large table also. And for that, what we do is we partition the table based on CTIDs, which is like a internal tuple identifier for Postgres. We logically partition it and parallelly stream it to the target database. So at a high level, right, like we start like a snapshot connection, parallelly copy tables, and also if there is a larger table, we can parallelize the load of that. Now the advantage of this feature, right, is terabytes of data could be copied in few hours versus days, basically. So for example, pg dump does not allow dumping like a single large table in parallel. It needs to be partitioned, and there is stuff like that, right? So that's the value of this. And obviously under the covers, to stream it to the target, right, we use copy with binary, right? Like we copy the data out, basically, and then we copy stream it to the, if it's Postgres, we use copy with binary. If it's Snowflake, we use we convert it to Avro format, and which is suitable for like Snowflake, and then stage it, and then like load it into Snowflake, right? So this is how we do the initial snapshot, and it doesn't make sense, Dennis.
And yeah, and the question, like, real stupid questions to two of you folks, like the snapshot connection. Is this something that exists in Postgres? Because I've never heard this definition, the snapshot connection.
Yeah, so it does. So when you actually create a logical replication slot, right, it gives a snapshot also, basically.
I see. Okay.
So we keep that like, a connection open, and that snapshot persists, basically. And we use that snapshot to get data from these tables, Dennis.
Makes sense. Okay,
And
let's.
Yeah, and it's really interesting to get it in parallel, because I think that to do this initialization, this blocks the vacuum on the source, because you need to read as of a point in time. So it's important that it is fast, even if people may think, oh, it can be slow because we are migrating and then we will apply the changes. It's much easier if you can control the time it takes. Yeah.
Yeah, exactly. So it does. For example, pg dump also would like lead to a long running transaction, and that would block vacuum. Here also, like we keep the snapshot connection open, but because of the parallelism, it will be faster. Now obviously, and that takes me to the next thing. So we also give configurability to set the parallelism, right? Like, so you can specify, okay, number of tables I want to do in parallel, number one. Number two, for each table, how many threads should I use, basically, right? So here I'm saying, number of tables is 3, and I want to use like 4 threads per table, basically. So it would under the cover spin up like 12 threads, right? and based on how much load you can put on the source, you can decide it, right? Like it's okay, you have like a bunch of room on the Postgres database, then you go with larger number of threads, or you just choose like one, right? Like it would just like work out of the box. So and then we have like, the third thing, which is like number of rows that it should read from each table at a time, right? Like which is like 500,000 if you're seeing here.
And in this example, for instance, you would start 12 threads within your Rust process, right?
Within Go, basically.
Everything Go. But
Yeah.
okay, and those 12 threads, will be they using a single connection to Postgres or several connections to Postgres?
So they will use several connections.
Okay.
And we can make that like, single connection. If you use PG Bouncer, sure, like, I mean, it'll use limited number of connections. But I mean, that's the reason we give this level of configurability, right? Like if you can put more load, you do, or else you just go with single thread, Denis.
Okay, wonderful. Let's go forward.
Awesome. So let me kick off the mirror now, right? And let's go for it. Awesome. So the mirror has started. So it should start streaming changes from, the source peer to the target peer. Let me go ahead and run a count on the target peer, right? And remember that that table did not exist, basically, right? Okay, the initial snapshot is already completed, right? And data is getting loaded, if you see, right? Like, and let me also directly connect to the target. If you see, this is what I showed you. And if you remember, previously these tables did not exist, right? Like now, the accounts, branches, and tellers existed, right? Like, I mean, they are created, right? And then the initial snapshot is done. And then we also provide like a, you can directly look at temporal, right? Like, and, monitor the status of the mirror, right? Like, so here, if you see, right, like I just go here, right? And then, so the if you see, right, like sync flow means that like the CDC is going on, basically, right? Like, and it periodically polls the logical replication slot and puts it to the target, right? And there is something called as snapshot flow, which is not here, right? Like, so you can go here, basically, right? Like, so this is the snapshot flow, which actually was the initial snapshot, right? Like, and if you see, this is already completed, right? And the number of threads also you can see here. Basically, they are called as like, partition flows, right? Like, so this all is documented, but at a high level, right? Like you can use temporal to monitor, the status of the mirrors. Currently, it means that it is basically in, logical replication, right? And, we can even see whether the updates are getting replayed. I would always love to query from PeerDB. So this is the advantage, right? Like you're, querying both the source and target from this layer, right? And I can just like change this to, Postgres_peer, right? And then you can see that like it's almost catching up. Around 300 rows are like different. Let's see also whether the updates have, applied. So in the update, I'm just like making this as -1, right? Like, so around 77,000 are there on the source. Let me also see how much are on the target. It will be slightly, behind, right? And it's called target_Postgres, basically. So target_Postgres, 77,000, and then like, this is the source, and this is the target, basically, right? So this demo shows, how easy it is to start, replicating changes from Postgres to Postgres. The parallel snapshot feature lets you do initial snapshots very fast. Terabytes of data can move in few hours versus days. And CDC is also going on, where like, inserts, updates, and deletes are replicated to the target database. And I can get into how we do that as well. But any questions?
Yeah, we have a question from Tyler, from LinkedIn. This is fantastic, Sai. How does this differ from existing tools such as Debezium? I think that you partially answered this question, but as a summary.
Yeah, I think first difference is basically the parallel snapshot, which I covered. Number two is basically on the change data capture side of things, right? Like if you were to use Debezium, you would need to basically push them to Kafka, right? Which is the, which is one step. Then you need to write a sync to capture changes from Kafka to the target data store, which is like Snowflake or like BigQuery, etc. That is number 2. Number 3, there is another step where once the raw changes are there, you need to also normalize it to the final table, right? So at a high level, like Debezium works, but like the number of moving parts are higher. That is number 1. Number 2 is like on this change data capture side of things, right? We do more like an ELT where like we capture the raw changes from the slot, right? Use the copy command actually, right? Like and then put it to the target, right? And then we do like a merge statement which will take care of the inserts, updates and deletes. And some initial benchmarks with like this approach, right? Like what we observed was it scales to like over 10,000 transactions per second on average, the ELT approach, because you're using the copy command here, right? Like to capture these changes, raw changes, and you're doing a bulk operation on the target Postgres database. You could do this with like Debezium also, but like it really depends on how you have the sync connector, right? So 3 differences, like the parallel snapshot for like faster like initial snapshots of larger data, number 1. Number 2, basically it avoids like multiple moving parts, right? You just like create this mirror and data gets replicated to Postgres or Snowflake or like anywhere, right? That's number 2. And last but not the least, we do an ELT which lets you give like large throughputs for change data capture. We have seen like over 10,000 transactions per second getting replicated with very minimal lag, Tyler. So
Okay, all right. Yeah, I think this should answer the question. So, but actually, before I know that you prepared a demo for Snowflake, but as long
yes.
as we are talking about Postgres right now, YugabyteDB is very related to Postgres because it was built on Postgres, it's distributed Postgres. So, like, why don't we let you take a quick break and let Frank to show how it works with YugabyteDB, because you created PeerDB for Postgres, right? That ETL tool
Yes.
for Postgres, but then you discovered that hey, it also works with YugabyteDB. So that's actually a good example of YugabyteDB compatibility with Postgres that you folks can also enjoy in your projects and applications.
Yeah, I'm sharing my screen. So I've seen the time going. So I already started it while you were doing your demo. Basically, I've started PeerDB with Docker Compose that is provided. I connected to it and created the peers exactly as you have as you did it. And in this other pane, let me go to the beginning. I started a Postgres instance. Let me put.
Oh, Frank Frank warned me that he's in the hotel might not have the best connection. So Frank, if you can hear us, we lost you. But yeah, like let's give him some time to return because anyways, I have questions for you.
I can also do the Yugabyte demo, Denis. So yeah.
Okay, let's give him some time, like, and if he
Yeah.
returns, he'll finish. If not, we have me copy and paste question from LinkedIn. So the next question is from Sudhansu. Sorry if I mispronounced the name. Does the limitations of Postgres logical replication apply to PeerDB as well?
So that's a good question. So to some extent, it does. For example, number 1, right? Like I'll give you 2 scenarios where actually PeerDB does something extra compared to what the standard tools do with like logical replication. The other is like where we lean on logical replication. So the first is toast columns basically, right? Like, and one problem with like logical replication is it does not like capture like unchanged toast columns as a part of like the CDC stream, right? Like, and then so typically these clients, right, like which like PeerDB needs to query the toast column for each row, which can be very, very expensive basically, right? So under the covers, like we have some optimization there where we keep state of like the value of the toast columns before. So at a high level, like toast column support is very efficient with PeerDB because we cache the toast columns on the target. So it's efficient then, so there we do something more than what logical replication offers, where we cache the previous value of that toast column, and then make sure that the unchanged toast column row has this toast column, right? So that is number one. The second scenario is for schema changes, right? Like where, okay, if there is like a schema change on the source, we lean on logical replication. So logical replication also gives you like relation messages, which let you, which gives you like whether a new column is added and stuff like that, right? And we use that to, create, also change the schema on the target, basically. So now the problem with that is, whenever like you create a column, right, like add a new column on the source with a default value, right, like say I set to -1 or something, logical replication does not give that default value. That is still not there in Postgres. And in those scenarios, PeerDB partially applies the column, so it does not do like a backfill of whatever is present, right? So at a high level, right, like if you add a column without default, it just works out of the box because you use the logical replication. If you add a default column, logical replication does not give me the data, right, like by which we support it partially, Denis, right? So that's the thing. So we do some, maybe down the line we work on submitting a patch to Postgres, and for getting changes for the schema changes as well in the logical replication. But yeah, that does it answer your question? So,
all right. So I think that, Subhan, so if it answers your question, give us a hi. If not, just you know where to ask a follow-up question. In the meantime, Frank, yes, as you predicted, we lost you, but let's get back you on track. If we lose you one more time, then Sai will show the demo.
I didn't predict that it happened exactly at the demo time, but that's usually the case. Yeah. So basically, I've started a Docker container with Postgres where I am running a PG bench, and so the difference with your demo, Sai, is that I've started the Yugabyte container with a lot of parameters because I'm very curious and I wanted to see all the queries. So I was using auto explain to see exactly the queries that are run. And as I did as you did, so it started to do the snapshot, put the first one, and then I've run PG bench on the source, and it's still running. And now if I look at the UI of Yugabyte, let me refresh that. I can see that I have activity on Yugabyte. I have reads and writes, because I think you get all the raw changes into a table and then you apply it by batches. So this is why we see reads and writes. We probably can see more information if we look at the live queries. Or maybe not the live queries because it's done by batch, so it's not always running, but we can see the kind of queries that are run by PeerDB. Here so that reads. I think there is you read. So
this is how you do the reverse engineering, right? You just capture the queries and see what's actually happening under the hood.
Yeah, finally, this is the insert into my target table, and it reads the information from the internal raw CDC table, and converts the data. So you store it as JSON, I think, and then you get the fields and cast them to the right to the right one, and you are using an upsert with the unconflict. Which is good. We still have an open issue in Yugabyte. We have an optimization for this, because for the moment, this on conflict insert, we read and then write, and we have the possibility of doing it like a real upsert. So as with Yugabyte as a target, there are a few optimizations that we may do, but let's look at it. If I stop that, and if I look just counting the rows on the source, here is, so that's the source, Postgres. I count and I sum just to check that I have the same, maybe not immediately because it's written by batch and I've run that with higher throughput. So it catches up the gap because I was inserting a lot. And yeah, there are things that can be optimized on Yugabyte, but and probably simply indexing will help because if I look again at the on conflict, it is on the key, and then if I have no index, it's probably doing a lot of sexcon, which maybe if we have 1 minute, maybe I can look at it because I've run auto explain to see even more what is running.
Love
Yeah,
it.
like
I love it.
you're like a surgeon. I mean, you always want to see what's like the
Yeah.
bones, the bead, like all that internal surveying.
Because
Oh my
when you
God.
see the execution plan, then you can really improve something. If you don't see, you are just guessing, and we have this conflict.
Wow, it's doing a sequential scan on the PeerDB raw mirror. I mean, I thought that there was an index on that, but if you see,
Yeah, that's so sequential scan on PeerDB, and where is the account table?
Yeah.
Oh yeah, you have also deletes of course, because the on conflict inserts takes the inserts and the updates, and you have also to apply the deletes there. Yeah.
Okay.
Yeah, really nice to see that.
Here,
Yeah.
here you go. Like,
Awesome. I
yeah.
love it. Yeah.
It creates it uses the index on the target. Yeah, the primary key. So that's also nice. The primary key was created automatically. That's what I like. You don't have to pg dump on one side and then do apply the logical replication. You have a tool where you just declare. That's the spirit of SQL. You declare pairs, you declare mirrors, and then things happen in behind you.
Okay, finally, Sai, you've got a certification from Franck for PeerDB. He reviewed like a quick review, like what's happening, like some of the inefficiencies, some of the things that are handled properly. So Franck blesses you to go in production. Thank you. Jokes aside. Thanks a lot.
No, the thing is that like I mean, Frank before the session said that like he would go into the guts of it. I love it that he has auto explain. I mean, that's pretty cool. So yeah.
But the advantage of that is that when we know how it works, I see exactly what can be optimized for Yugabyte as a target. And also from what you explain, already see what can be done to get Yugabyte as a source, because you mentioned the city ID. We don't have a city ID because we have a different storage, but we have a hash code, we have tablets, and then we have other ways to parallelize. So yeah, when you understand how it works, then
I have one good news. I have one good news, Frank. You can actually specify that partition column also. So you don't need to specify CTID. You can specify the primary key also. So we can do that as a part of, it's in the table mapping. You create a JSON where you specify the partition column, and under the covers, like PeerDB picks up and partitions based on that column. So we can talk about this offline, but yeah.
Perfect.
Excellent. Yeah. So wonderful, thanks. So we no longer have time, folks, for the other demo, like Sai planned to show how to stream from Postgres to Snowflake, but we trust you, Sai. And nevertheless, like you can always find Sai like on our community Slack, and you can find him on social media. Probably he will be happy to show you how it works, like personally, depending on who you are and how you're interested in the solution. But in the meantime, I just one thought that I want to highlight, because some of the folks who are watching us, they might already be using YugabyteDB Voyager, which is a migration tool that was created by YugabyteDB, and there is definitely intersection between PeerDB and Voyager. So, like, just to clarify, because PeerDB was created and is created and being developed for Postgres, right? The Postgres is the primary user, the primary platform, source and target, etc. But also for the target, you have different databases, and the guys are optimizing it. YugabyteDB as a Postgres-compatible database is distributed, is lucky enough just to get this also capability. While Voyager is the concept of Voyager is similar to PeerDB, but with the purpose that their target database is always YugabyteDB. So like Voyager can capture changes from Oracle, Postgres, and other databases, but then it optimizes everything for their YugabyteDB as a target. YugabyteDB is always a target, while in PeerDB, you have other target databases. So like PeerDB is right now, at least right in my understanding, your focus on the real-time streaming ETL, while Voyager is focused only on the migration process, like offline migration plus online migration. This is we were already adding that, but still, it's wonderful that two tools exist, and that's wonderful that what you folks created for Postgres also works for YugabyteDB. And also just to clarify that, because Amit, you answered like the very first question was from Amit. Let me find it here in the list. He asked that does PeerDB works with YugabyteDB? It does, but right now it does work only if YugabyteDB is a target, right? Because YugabyteDB doesn't support the logical replication of Postgres. We don't have a need for that. But who knows? Like probably some.
Actually, we have changed data capture, and I think it's still in beta, but we have changed the data capture that uses the same syntax as Postgres, but we have a different format for the changed data capture because there are different information to ship with it. But yeah, that's probably a possible evolution.
Yep.
Yeah. Any final closing thoughts, Sai and Franck?
No, I love it. I think you
That's
summarized
perfect.
it well. Yeah, the thing that impressed me was like I just like tested Yugabyte as a target, right? And it just worked out of the box. I mean, that like was good because I know I've worked with distributed like Postgres databases, right? Like no need of sharding, and the automatic sharding was like very unique. So I just created the tables, and under the covers it created these tablets and like automatically, right? And it just worked. So that was pretty impressive. So yeah, thanks for the opportunity again, Denis and Franck.
And the documentation is really good because I looked at it from the documentation, even if it's short, that are all the commands and that works. Yeah.
Okay, wonderful. Yeah, thanks a lot. And thanks, Sai, to you and your team for making Postgres great, because what you do makes Postgres more powerful, and it eventually will expand its usage and use cases. So keep doing that, and we wish you luck, financial luck, like for again, success to the project. And if the success to the project comes, then also, we wish the luck to your company. So, and let's see, like let's meet a bit later, like once you get through several milestones, and see how the story will look like in a half a year or in a year from now.
Absolutely, Denis. Awesome.
All right. Thanks a lot for yeah. Thanks a lot, everyone who joined us today, who found time to watch us live. And thanks a lot for asking the questions. Hope you loved PeerDB, and hope you loved what Sai and his team is doing. And if you're watching us, will be watching us on demand, just in case Sai is on the YugabyteDB community Slack, you will be able to find him, or you can always find him on social media. Okay. Bye-bye, everyone. Enjoy the rest of your day.